Hi, everyone, and welcome to AstroNights Live. Once again, we have a fascinating presentation planned for you, and we're very excited that you chose to spend a little of your time with us tonight. Our presentation will be about 20 minutes in length, after which we'll be able to address a few of your questions. Those of you participating on Zoom can post a question via the Q&A window. Be sure to hold your question until the end because it just might get answered during the presentation itself. If you're joining us via YouTube Live, you should know that Q&A is not available, so just sit back and enjoy. Whether you're joining us on Zoom or YouTube, we recommend taking a moment to locate the full screen mode in your app for the best AstroNights Live viewing experience. All of the websites and resources we'll be discussing during our program are available on our website. So don't worry about rushing to write them down. Just relax and enjoy the program. The links will be waiting for you whenever you're ready. You'll be invited to complete an online survey at the close of the program, and we hope that you'll take a moment to share your thoughts with us. Your feedback helps us in planning the future AstroNight Live events. And now I'd like to introduce you to our presenter, Mary McDonald. Mary is the Planetarium Programs Manager at the FSU Planetarium, and I know she's anxious to get started. Mary?
Thank you, Brenna. Good evening, everyone, and welcome once again to AstroNights. We're going to start today, as we often do, with a poll. Or a question/poll. Everybody, if you're watching together with a group of people, I would like you to discuss this question with each other, ask each other what you think. The question is, which planet in the solar system has the most known moons? And for those of you on Zoom, I am actually going to allow you to respond to this as a poll. So ready? Everybody on Zoom should now be seeing a poll that they can respond to. I'm not going to give you that much time to answer this because I know that you could probably look it up pretty quickly, but don't do that. See if you can think about it. It's fun, right? It's trivia. Which planet in the solar system has the most known moons? Those of you that are on YouTube right now, please do be aware that you are more than welcome to join on Zoom in the future, or if you wanted to try tonight, you can get a little bit more interactivity that way. You can respond to polls like this and ask questions that I can respond to. All right, last few people. Respond to that poll, hit submit, and 3, 2, 1, that's all the time you get. Okay, so let's see the results. So we have mostly people saying Jupiter and Saturn, and if your first thought was it's gotta be one of those, because that's the theme of the show tonight, good thinking. I like that attention. And it definitely is one of those, but which one is it, Jupiter or Saturn? Well, up until about a year ago, the answer would have been Jupiter. Jupiter had the most known moons at that time, and that's why I don't say which one has the most moons. It's which one has the most known moons, the one, how many do we know about? And just recently, some moons new to us were discovered at Saturn, and Saturn now has the most known moons in the solar system at 82. Wild. So I'm going to close that poll, and we're now going to head over to take a look at our night sky. And we are actually going to see these two solar system bodies tonight, Jupiter and Saturn. I do want to ask for you all to please be patient with me tonight. Like many of you, I am dealing with some extreme hot weather, and I have had to make some changes to my technological setup here. So I don't know what to expect. All right, I'm going to transition over to a lovely scene of the night sky. Which, I mean, looking out my window, this may be pretty similar to what's actually happening. I see the sun setting just about now, although it was raining just a moment ago. And we have Tropical Storm Faye on the way. Always something interesting going on here in New England. But should we have clear skies, there's a lot of interesting things to see in the sky tonight. All right, so let's let the sun set. We're going to go forward to, oh, and I'm going to hide my video now. We're going to go forward to about 10 p.m. We still have to stay up pretty late to get a nice dark sky, but that's changing as we get farther in time from the solstice. All right. Now, it's 10:05 at this time, and we are going to be looking for 2 bright planets in our night sky, and I believe I have already revealed that they are the planets Jupiter and Saturn. You may have to pivot just a little bit. Okay, there we go. So, where are these planets? Your eyes may possibly be drawn to this object here. But if you were with us for the last AstroNights, you may remember that that is not a planet at all, but a star. That is a red-colored star named Antares. And we talked about how that name Antares means the rival to Mars, because it is red like the planet Mars. And many, many people do mistake that star for the planet Mars and have for a long time. Anyway, Antares is part of this constellation called Scorpius that I pointed out as well last time. This is a pretty easy constellation to find in the sky. It's got this nice curving path of stars that definitely gives you the impression of a scorpion's body and tail. Now, right next to Scorpius, we have another constellation. This one is known as Sagittarius, but I must tell you that the shape of this one is not quite as easy to pick out. In fact, many stargazers have a different name for this pattern of stars. Many of them refer to it not as Sagittarius, but as the teapot. And once you see it, you can see why. It really has that nice little teapot shape. So why am I pointing out the teapot of Sagittarius? Because that is where we are going to be looking for our 2 bright planets. So right to the left, am I not sharing anymore? Okay, sorry if I stopped sharing for a moment. So there, I hope you're all seeing the night sky right now. Anyway, just to the left of the teapot, you have the planets that we are looking for. So they're very bright. They're pretty easy to observe. And the brightest one is Jupiter. And the slightly less bright one to the left is Saturn. Now, I know tonight's program was called Jupiter and Saturn, but I am going to tell you that we are not going to talk too much about Saturn tonight. That will be the focus of the next AstroNights. So we do hope you will all join us and tell your friends. So today we're going to talk a little bit about Jupiter. But first, I want to just let everyone know that this whole scene might appear to be pretty close to the horizon, and therefore that may make it a little bit difficult to observe if you have trees or buildings in the way. But the 2 planets, Jupiter and Saturn, look, there's the date, throughout the next few days, they will appear higher and higher in the sky. So look, we're going forward in time, and you can see that these planets are going to just rise up higher and higher, so they will be more easily visible all throughout the summer. So it's really going to be the summer of Jupiter and Saturn for all of us. All right, back to today. Today, not too bad. You just have to stay up a little bit late. All right, let's take a closer look at Jupiter. Now, if you do get a chance to observe Jupiter, this is often one of the very first things that people want to look at with a telescope. And in fact, it may be the very first thing that anyone ever did look at with a telescope, in the sky, that is. That's because Jupiter was the first major object, well, maybe not the first. It was one of the first major objects to be observed by Galileo Galilei, who was the first person to ever observe the planets with a telescope. So what we're going to do is we are going to zoom in on Jupiter to get a view similar to what a pretty good telescope might show you. So before we do that, I want you to all turn to each other and talk about, if you were to look at Jupiter through a telescope tonight, if it's a nice clear night, what do you think you would see? What do we know about Jupiter that might possibly be visible to us? So as you are thinking about that, we are going to turn our imaginary telescope towards Jupiter and get a closer look. This may take a while. Okay, so we're thinking about our predictions that we made. Anyone's predictions correct or totally incorrect? Wow, that is just lovely. Now, some of you may have been predicting that you might see the very, very famous feature of Jupiter, which is the Great Red Spot. And in fact, that is something that you can see with a telescope. Even a pretty small telescope can reveal the Great Red Spot. But we don't really see it today because, of course, Jupiter does rotate. And so sometimes you see the spot, sometimes you don't, depending on what time it is at Jupiter. All right, so what we do see is we see a lot of the beautiful colors. We see a lot of the swirling shapes. And I'm going to just turn on my video very quickly. If you're a regular AstroNights attendee, you should know that my backgrounds are always a little bit of a clue to what we're going to be discussing, but never obvious. So what you're seeing is actually an amazing, an amazing high-resolution image captured by the Juno spacecraft, which is currently orbiting Jupiter and getting these amazing high-resolution images. So I thought this was a great one for today because, wow, just look at how beautiful it is. I should just get out of the way. You should look these up, Juno high-resolution images. They show lots of this swirling gas. Jupiter is just basically in a constant state of hurricane season. It's all these, they call them vortexes and storms and jet streams. It's just wild weather there. And in fact, the Great Red Spot itself is probably the most famous gigantic storm. Okay, let's turn that video off for now, but certainly look up those Juno images. Okay, so let me zoom out just a little bit. That's a little too much. The other thing that is really great to observe with Jupiter is Jupiter's moons. So in your view right now, you actually have a couple of stars that are kind of in our way. But aside from those stars, we have the four they're called the Galilean moons, because these were observed by Galileo. And that tells you how large they are and how easy they are to see because he had a very, very primitive telescope. So the moons are called Io, Ganymede, Europa, and Callisto. And we're going to take a closer look at each one of them. So here's Io. And the really great thing about these moons is that they are very large, very complex. They're often known as worlds in their own right. And they're all very unique. So Io is officially the most geologically active object in the solar system. That means it has the most active volcanoes, over 400. Yes, it's even more volcanic than Earth. And it was the first place in the solar system besides Earth where volcanic activity was ever observed. The next one we're going to look at is Europa. Europa, very, very interesting object in the solar system, you see that kind of whitish color and those crisscross lines. So Europa is a world of ice. So isn't that crazy? A volcanic world and a world of ice in the same system. But think about it. If you saw a lake frozen, but it had a bunch of lines in the ice, what might that tell you about the ice? That maybe it's not the best ice to walk on, not totally solid? Yeah, absolutely. These lines are cracks and wrinkles in the ice because it's not solid, frozen. It's actually a liquid water ocean underneath. So that's why this particular moon is so interesting, because it is thought to be one of the best potential places to look for life in the solar system because of the amount of water that is there. Next up, we have Ganymede, which is interesting because it is the largest moon in the entire solar system. No other planet has a moon larger than this one. And finally, Callisto, well, maybe not the most interesting of the group, but it is the object in the solar system that has the most craters. So there's a lot of interesting and record-holding worlds here at the Jupiter system. And the great thing about these moons, as I said, is that even with a very small telescope, you can observe them yourself, and you can put yourself in the shoes of Galileo. Observe these night after night, even for just a week, and you will see the same thing he saw, which is that the moons do not stay in the same position. One night they'll be on one side of Jupiter, and then the next night they'll be on the other. And this simple observation led him to the conclusion that these moons were orbiting around Jupiter. And it was such an important breakthrough because at that time, the general opinion was that everything in the sky orbited around the Earth. And he was able to provide proof that there was something out there that was definitely not orbiting Earth. And it really led to an entire revolution in our understanding of the solar system. All right, so we are going to zoom back out a little bit more. And now we are going to turn towards the east. All right, everybody, let's turn towards the east. Oh, it's a little too far. And east is the direction that you want to look in. I should probably turn that off there. We don't need that date. East is the direction you're going to want to look in if you are bored of what's in the sky now and you want to see something new. Because just like the sun, everything in the sky, the stars, the planets, the moon, rise in the east and set in the west. So if you look towards the eastern horizon, you will see new things appear in the sky that we haven't seen yet tonight. And at around midnight, you will see the lovely moon come up. This is around its third quarter phase, which the phases, remember, do not only affect how the moon appears, but they also are going to affect the time that the moon rises. So right now we have a moon rising pretty late in the evening. And just above the horizon, you should have seen a very, very bright light appear. And that is the planet Venus. So a bonus planet that we didn't even really advertise we were going to talk about today. We generally try not to get you all waking up early in the morning to see planets. So that's our reasoning there. But we do want to perhaps encourage this tonight because there has been something interesting in the news recently that you may have heard about. There we go. So if anyone has heard recently about a comet that may be visible in the sky, we wanted to make sure that we addressed it. And right now, starting tomorrow morning, the early dawn around, this is right now around 4 o'clock in the morning, is the best time to possibly see this comet. The comet is known as, in the news, it's being called Comet Neowise. And, oh, you know why it's not visible? Because I have comets turned off. There we go. Oh, spoiled it already. So what I meant to say was this is not what it is going to look like. Okay, everyone, let me repeat that again. You are not going to see this in the morning. This is not what it's going to look like. This is the fun little simulation animation of a comet. And this is what comets can occasionally look like under certain circumstances. This is not what you're going to see tomorrow, if you possibly saw it at all. But this is marking the location of it. So how can you look for this comet? Well, actually, tomorrow morning, if you happen to observe Venus, that might actually help you. You can also look out for the constellation Auriga, which kind of looks like a little house and has this very bright light Capella, or very bright star called Capella. So that's the constellation Auriga. Here's Capella, and Comet Neowise is just a few hairs downward from that. Now, remember everyone that comets are moving. Just like planets, comets orbit the sun. So remember, there are these things that orbit at very, very large distances from the sun. Unlike the planets, they have very elliptical orbits, so they're not circles. And that means that at one point in their orbit, they get really close to the sun, and then they go really far away, and it takes a long time for them to come back. So this particular comet has a period of around 6,800 years. So this is our chance to see the comet. We will not get another one. And it is one of the few comets that may actually be visible to the naked eye. So let me just give you a little quick look at where the comet will appear in the next few days. So this is where it will appear today. And in the next couple of days, it will continue to be visible in the early morning. But as you can see, it is not staying in the same place with respect to the stars. Neither is Venus. And that is, again, because they are in motion around the sun. So what are you seeing here with this comet? Well, comets are often described as dirty snowballs. They are balls of ice and dust and rock. They're usually pretty small. As I said, they orbit the sun at very large distances. And when they get close to the sun, and only at that time, suddenly they get really hot. So you heat up this snowball, the ice starts to evaporate, and it blows off the as it's traveling really fast, as it gets close to the sun's burning off that ice and dust, and so we get this lovely dust tail that trails out behind it. So this particular comet, Neowise, was discovered in March of this year by the telescope Neowise. So comets are usually named after the person that discovers them, but these days it's more likely that comets will be discovered by spacecraft or telescopes without really any person's help. So it's kind of nice. They're not named after the person that discovered them. They're named after the telescope that discovered them. And there are actually many comets. There have been 33 comets discovered by the Neowise Space Telescope. So this is not the only comet Neowise, but this is the one that is probably the more visible than some of the ones in the past. So supposedly it is visible with binoculars or a small telescope, and supposedly even with the naked eye. On our website, which I'll show you in just a moment, I have put some links about the comet, including some really, truly amazing photos that people have taken. But I will say that here, if you're with me in New England, it's going to be a bit tough. We are also in the middle of hurricane season, and the skies just are not cooperating and being clear. So I encourage you to feel happy for those that can see the comet and look at their amazing photos. So with that, I'm going to wrap up and ask if anybody has any questions. Please put them in the Q&A. I'm going to give everybody a little bit of time to write their questions. So any questions you have, put them in the Q&A, and I will get to them in just a moment. But I did want to take one moment of your time to just go back and remind you about our website. Okay, so I'm going to share that. Our general website for the Krista McAuliffe Center for Integrated Science Learning is cmcenter.org. It's really easy, cm-center.org, I should say. Very easy to understand. And everything that sort of me and my team from the FSU Planetarium have put together is under this initiative, From the Dome to Your Home. And AstroNights really is the most important program that we've produced in this initiative. So if you go to the AstroNights page, each event has its own event page, and you will see that we do have more upcoming programs, so please mark your calendars. And if you go to tonight's event page, first of all, if you want to share this with your friends, this is where you'll be able to access the recording later. And we've put a bunch of resources here. I just added a lot of stuff about Comet Neowise, and this Sky and Telescope article really does have some fabulous pictures. And I'll probably add a couple of more things because I've just done so much research about both topics, actually, or all the topics we've discussed in the last couple of hours. So check back there. All right, so with that, I want to go back to the night sky and ask again for questions that you may have about anything that has come up tonight. Okay. So, question. I have a question, and it is on behalf of Nico. So I hope I am speaking to Nico right now. What is the black spot on Jupiter? I assume you are talking about, and now, unfortunately, I'm the one that started this. Now I have to follow through. I have to show myself again. You're probably talking about this little black hole behind my head. So the crazy thing is about this mission, the Juno mission, is that you are getting these amazing high resolution images that are unlike anything we have seen at Jupiter before. So people are seeing things in these images that they do not know, they do not understand, they don't know what they are. But generally, sorry, I'm trying to get out of the way so we can see this black spot. Generally, this is being called just a vortex. So like a spinning vortex, like we have those polar vortexes on Earth that cause really cold weather that they like to make they like to make these names for things. And this one just happens to have a particularly dark center. So when it comes to the colors, I will say that these are not exactly true color images. They may sort of play around with the colors, but where you see these differences is definitely areas of very high contrast. So is it true black? Are the other things around them this true blue? Maybe not, but this dark area was definitely a place that was super dark and super dark compared to the rest of the material around them. But that's just the crazy thing about this mission, is that it's creating more questions to explore than immediate answers. And if Nico, I hope I'm not reading this wrong, but if Nico is a young person, I would like you to know that this data coming back from the Juno mission is creating so many opportunities that young people are going to be studying this data for many years to come. So sorry, I can't tell you what it is. Okay. So great question here from Ginny. How do you figure out a comet's orbit? Where does this comet go for the other 6,000 years? Okay, so the really cool thing about that, and let me hide my video again. The really cool thing about that is that you don't need that much information to figure out the entire orbit of an object. You just need to be able to watch it for a couple of days, and then you can get a sense of its trajectory, which I think is very, very cool. And that's because of how much we know about the behavior of objects in orbit. For hundreds of years, we've been studying how objects move around the sun, starting with the planets, and we really now know, how to predict what path they will follow. So if you're able to observe it for probably a couple of days is all you need, you'll be able to figure out exactly what its orbital path will look like. So I wonder if I'm going to be able to show you this, everybody. So bear with me for a moment. I'm going to try something. I want to show you how this object is orbiting the sun, but I really can't. I'm having a little bit of technical difficulty with this, but I encourage you to look at the resources about Comet Neowise that I put on the website, because you'll see a little bit about how the path of the orbit looks. And I want you to imagine, like, and I should probably go back to our comet scene. I want you to imagine like an oval, a really, really flattened oval. It's not a circular orbit like the planets. So it's an ellipse. So yeah, unfortunately I can't show you this. I'm having a little technical difficulty with it, but you can find really, really nice drawings of that in the resources that I shared. All right, I need to go back and show the comet again. Where's my comet? Do I have comets turned off? Yes. There we go. There's Comet Neowise and Capella and Auriga. Okay. All right. More questions. Questions really like to come in. How bright is Capella? That's a good question. It is a very bright star. It is one of the brightest ones at this in this part of the sky. I can tell you a little bit more about it. Let's see. So I'm not going to tell you the number that represents how bright it is, but it is one of the brighter stars in the area, in that part of the sky. But if you look right next to it, at the planet Venus, let's see. Oh, yeah. So Venus is about 1,000 times brighter than Capella, though. So that's a really good way to kind of, that's how astronomers talk about brightness, is they sort of compare one object to another. So in reality, you might not be able to see the difference here, but there's going to be a huge, huge difference in brightness between Venus and Capella. But Capella is still one of the brightest stars in the sky, so that should tell you how dim the other stars are. Now, the comet Neowise is much dimmer than both of these things, and Neowise is much dimmer than most of the stars. The reason why it is visible to the naked eye in certain circumstances is because of the long tail. So the tail is not going to be as long as it shows here, right? This is not a picture of the comet. This is an illustration. But the real comet tail is pretty long, and that's what makes you that's what makes it a little bit easier to see in the sky, because you can look for that extended line in the sky. I really, really encourage you to look at the Sky and Telescope article that has real photos of the comet. And I do just want to say again that most of these photos are taken from places that have really, really dark, clear skies. And unfortunately, a lot of us don't have that. So that's part of it as well. Okay. Okay, let's see. All right. Let's see. Great questions here. Lots of good ones. So hopefully I can get to some of these. All right. So question from Susan. Are the craters on the last Jupiter moon the results of objects hitting the moon? Yes. So absolutely yes to that question. That's pretty much the result. That's what causes all craters. So there are craters throughout the solar system. And I will take this moment to plug one of our previous programs that we did last week, actually. We did a program on International Asteroid Day. So asteroids and comets are different. They are different things, but they both are objects that orbit the sun, and asteroids are frequently known for hitting other objects. And we talked a lot about that. But anyway, throughout the entire solar system, including on asteroids themselves, but definitely on the moon, on Jupiter's moons, even on Earth, there are craters, and they were all caused by objects hitting those other objects. The study of craters is really, really important, because seeing all these craters on objects in the solar system, gives us a lot of clues that a long time ago, there used to be tons of objects in the solar system. Everything was getting bombarded. And when we see an object that has a lot of craters, we know that that object hasn't changed. And we can look at those craters and kind of piece together the history of what happened to that body. Now, if you compare that to another moon, the other one, Io doesn't have any craters on it. But that doesn't mean it never got hit by anything. It just means that because of the volcanoes, new molten rock is covering the surface and effectively resurfacing the moon so that we don't see the craters. So when you see an object that has lots of craters, you know that it hasn't changed in a long time. So our moon hasn't changed in a long time. Earth, on the other hand, has changed. Our surface is getting changed by water, volcanoes, earthquakes, things, wind, everything like that, all the time. But we still do have evidence of craters on Earth that just haven't had time to be covered up yet. Okay, let's see. Other questions. Okay. I'm going to admit to everyone that I have some questions that I don't know the answer to. But everyone should know that I do keep all of our questions, and we are always in talks of saving all the questions that we get and doing a program where we address all the audience questions, including the most popular ones. But I can look at one here that says, is there a theory that Neowise of Neowise hitting Earth? So great question, and certainly the way certain news articles portray it, they might kind of make it seem like that's possible, but no, there is no theory that this comet will hit Earth. It will get close to Earth, and in fact, its orbit will intersect with Earth's orbit. So, and again, I'm really sorry I can't show you these visuals, but imagine the orbital path of the Earth. The comet will pass, it will go through the inner solar system, and it will cross over all of those orbital paths. But that doesn't mean it's going to hit any of the planets, because just because two paths cross, as long as the two objects are not in the same place at the same time, doesn't mean there's not going to be any collision. And it's actually not going to get really anywhere close to Earth. It's still going to be very far away, even at its closest approach. And that's really just due to, as I said, how strongly we are able to predict the orbital paths of objects just from observing them for a short time. I can tell you that the closest approach to Earth is going to be on July 22nd, and it's going to be about 64 million miles or 100 million kilometers from Earth, which is a pretty big distance. Okay, great question. So I think I'm going to wrap up the questions for now. And again, please do continue to join us for AstroNights events. And another thing I can do is I can continue to put resources on our event page that will help address some of the questions that you might have. And we hope to see you again in the future. Thanks everyone for joining us, and have a lovely weekend, everyone.